Polynomials. Relationship between zeros and coefficient of polynomial. Relationship between zeros and coefficient of polynomial in linear polynomial, in quadratic polynomial and in cubic polynomial. Division of algorithm for polynomials. Relationship between zeros and coefficient of a polynomial. Let us find the relationship between zeros and coefficient of different types of polynomials. Let us take a linear polynomial. P of x is equal to 2x plus 3. Suppose for x is equal to k, P of k becomes 0. It means 2k plus 3 is equal to 0. Therefore, k will be 0 of the polynomial. From the equation, we can get value of k is equal to minus 3 by 2, where 3 is the constant term of polynomial and 2 is the coefficient of x. In general, for a linear polynomial ax plus b, if k is a 0, then p of k will also be 0 and the value of k will be minus b upon a. That is, 0 of polynomial is equal to negative of constant term upon coefficient of x. Let's take now a quadratic equation 2x square minus 8x plus 6. We have learned how to factorize quadratic polynomials by splitting the middle term. So, here we split the middle term, that is minus 8x, in such a way that sum of two terms will be minus 8x and whose product will be first term 2x square into constant term 6, that is 12x square. Therefore, 2x square minus 8x plus 6 is equal to 2x square minus 6x minus 2x plus 6. Take 2x common from 2x square and 6x and 2 from minus 2x and 6. Again we can take x minus 3 common and last we get the factors 2 into bracket x minus 1 into another bracket x minus 3. Now value of p of x will be 0 if x minus 1 or x minus 3 will be 0. That is, x is equal to 1 or x is equal to 3. Therefore, 1 and 3 are zeros of polynomial 2x square minus 8x plus 6. Now, if we add both zeros, we get sum 4. 4 can be written as minus into bracket minus 8 divided by 2. We can see that minus 8 is a coefficient of x and 2 is coefficient of x square. Therefore, sum of zeros is negative coefficient of x upon 2 is coefficient of x square. And if we multiply both zeros, we get product 3. 3 can be written as 6 by 2. That is, 6 is constant term upon 2 is coefficient of x square. In general, if alpha and beta are zeros of polynomial ax square plus bx plus c, then sum of zeros, that is alpha plus beta is equal to minus b upon a and product of zeros, that is alpha into beta is equal to c upon a. Let us consider a cubic polynomial p of x is equal to 2x cube minus 5x square minus 14x plus 8. 4 minus 2, 1 upon 2 are the utmost 3 zeros of this polynomial because for these values we get p of x is equal to 0 if we check. Now if we add these 3 zeros, we get the sum 5 by 2. We can write 5 by 2 as minus of minus 5 by 2. We can see that minus 5 is the coefficient of x square and 2 is the coefficient of x cube. Therefore, we can write sum of zeros is equal to negative coefficient of x square upon coefficient of x cube. And if we multiply these zeros, we get the product minus 8 by 2. 8 is a constant term and 2 is a coefficient of x cube. Therefore, we can write product of zeros is equal to negative constant term upon coefficient of x cube. Now in cubic polynomial, there is one more relation here. Consider the sum of the products of the zeros taken 2 at a time. We have 4x into bracket minus 2 plus into bracket minus 2 into 1 by 2 plus into another bracket 1 by 2 into 4. And the result of sum of the product we get is minus 14 by 2. Now minus 14 is coefficient of x and 2 is coefficient of x cube. In general, it can be proved that if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b upon a. Alpha, beta, gamma is equal to minus d upon a and alpha, beta plus beta, gamma plus gamma alpha is equal to c upon a. Division of algorithm for polynomials. If p of x and g of x are any two polynomials with j of x is not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or degree of r of x is less than degree of g of x. This result is known as the division algorithm for polynomials. If remainder is 0, then we can call divisor and quotients. Both are factors of given polynomial. We know that a cubic polynomial has at most 3 zeros. Let us try to find other 2 zeros if one of 3 is given. Consider x cube minus 3x square minus x plus 3 and one of its zeros is 1. Therefore, x minus 1 will be one of the factors of x cube minus 3x square minus x plus 3. We can get second factor by dividing x cube minus 3x square minus x plus 3 by x minus 1. Now to get the term of the quotient, divide the highest degree term of dividend, that is x cube, by the highest degree term of divisor, that is x. We get x square. Write x square in the quotient, multiply x square with each term of x plus 1. We get x cube minus x square. Now subtract it from dividend. We get remainder minus 2x square minus x plus 3. Now consider minus 2x square minus x plus 3 as dividend and divide it by x minus 1. To perform division, first divide highest degree term minus 2x square of dividend by highest degree term x of divisor x minus 1. We get minus 2x, a second term of quotient. Multiply minus 2x with x minus 1 and subtract the result from minus 2x square minus x plus 3. We get minus 3x plus 3 as remainder. Now consider minus 3x plus 3 as dividend and divide it by x minus 1. To perform division, first divide highest degree term minus 3x of dividend by highest degree term x of divisor x minus 1. We get minus 3. A third term of quotient. Multiply minus 3 with x minus 1 and subtract the result from minus 3x plus 3. We get 0 as remainder. Therefore, we factorized x cube minus 3x square minus x plus 3 as x minus 1 into another bracket x square minus 2x minus 3. Now we need to factorize x square minus 2x minus 3 so that we can get all three factors. We can get the factors of x square minus 2x minus 3 by splitting the middle term minus 2x. Therefore, the factors of x square minus 2x minus 3 are x minus 3 and x plus 1. In this way, we get all the three factors of x cube minus 3x square minus x plus 3. Summary. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then sum of zeros, that is, alpha plus beta is equal to minus b upon a. Product of zeros, that is, alpha into beta is equal to c upon a. 2. If alpha, beta and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then sum of zeros, that is, alpha plus beta plus gamma is equal to minus b upon a. Product of zeros, that is, alpha, beta, gamma is equal to minus d upon a. And sum of product of any two zeros, that is, alpha, beta plus beta gamma plus gamma alpha is equal to c upon a. 3. The division algorithm states that given any polynomial p of x and any non-zero polynomial g of x, there are polynomials q of x and r of x such that p of x is equal to g of x, q of x plus r of x, where r of x is equal to 0 or degree r of x is less than degree g of x. So that is all in this subtopic, students. Maths is fun, so keep learning.